Hi everybody. Welcome to this edition of Tech Talk with Dave. We are going to introduce a new radio system from Telrad called the BreezeAIR AXE. It's a point-to-point or point-to-multipoint system. It in testing in my lab, I was quite impressed with the performance actually. Anyways, there's some features that that I want to talk about directly in this system, and we'll go from there. So here's some of the highlights of it. The same unit can be an access point, it can be a point-to-point master, or it can be a point-to-point slave or a subscriber module. Doesn't make any difference. They all look exactly the same. They look like this. And they have a data connection, a PoE. Ultimately, they're going to have a fiber connection to them. But at this moment, these test units that I have were Cat 5 only. So capacity, about 2.1 gigabits per second. The AX in the title of the equipment stands for 802.11ax or Wi-Fi 6. So these are running Wi-Fi 6 protocol, and some of the features of Wi-Fi 6, dynamic asymmetric resource allocation. Link can be in service in about 30 seconds. If you've done this once before, then you know exactly what steps you need to do in order to make it go. The unit is really energy efficient, low power consumption, about 13 watts per end of the link. And by Telrad's spec sheet, the range is about greater than 130 kilometers, which is far. I did not have a chance to test it at any more than about 15 meters across my office and basement. But it worked great. So they've got some secret sauce in the unit itself. They have an innovative and proprietary, by their description, interference rejection protocol that takes and eliminates interference. And I can say that I think this works pretty good. TDMA scheduler ensures a collision-free operation. That's part of the Wi-Fi 6 protocol. ACM guarantees an error-free link. That's the modulation levels run up and down according to the link quality. It has a very fast ARQ, minimum latency and jitter. Latency across my link about 3 or 4 milliseconds, and these things, of course, are time synchronized, so we avoid self-interference. So the equipment arrived. I was excited to see it come. The box that it shipped to 2 BreezeAIR AXE units were included, AXE units were included. They've got integrated antennas, as you can see here. The antenna's all part of the device itself. There was a cable gland, which is in the box with the mounting clamp for vertical pipe. And my lab setup at first included mounting both units on speaker stands placed about 15 feet apart. And you can see pictures there of how I turned them up. All right, so my test setup, very simple. Out of my core router into the master unit, across the RF link to the slave unit, ran them in point-to-point mode at first, and then into a laptop. And my test setup, units approximately 5 meters apart. I had 62 dB of path loss between the units. I set my transmit power to +1 dBm. My RSSI measured at the other end of the link was -33, and of course the link being in point-to-point mode was symmetrical. So I did the same thing on both ends, and away we went. When the units arrived, they were both configured as subscriber units. Logging into the GUI using the default IP address, it was easy. I changed the configuration on one unit to be a master unit and the second one as a subscriber unit. And then the only other step to make them join each other is to correct the MAC addresses so that you're talking to the unit in the opposite. On the master unit, you list the MAC addresses of all the subscriber units that you've got connected to it. On the subscriber unit, you list the MAC address of the master unit. Simple as that. Then I set the operating frequency, the bandwidth, and the transmit power in the master unit. I set the subscriber unit to scan all channels, and I enabled automatic transmit power control in the subscriber unit radio. So all of this falls well within a couple of minutes of perusing the manual and turning it up. So I configured my network. I set my IPs to this particular subnet that I needed to speak to my router, and I did not use VLANs initially. This particular router did not have IP version 6 available on the downstream leg of the router, so I could not test in this mode. I could not test IP version 6, but ultimately I did. And I do not have a syslog server that was up and running, and I don't have an SNMP server that's up and running. But if I did, I would just simply fill in the blanks for the IP addresses, the passwords, and away I go. With SNMP management and collecting the logs of the device. So the links came up, no trouble. In the GUI, I can see this end of the unit. I can see the opposite end of the unit. I can see what the downlink throughput ultimately is. I can see what the uplink throughput is. These are 6 gigahertz units, and so I set the channel size to 160 megahertz, and the frequency was to 6120, and my aggregate link performance was about 1850 megabits per second over the air, and the actual link performance was limited to the 1 gig Ethernet ports that I had on either side of it. So I was limited to about 920 or 940 in each direction of the device. But as you can see in the available throughput, that this link was capable of 1.7 gigabits in each direction. Pretty hot stuff for a light point-to-point like this. And the last step in a production network would be setting the passwords, the remote authentication IP. I would create a whitelist for who could actually log into this device, perhaps, and I would turn it loose in the wild, and there I am doing the throughput that I need. I could reduce the throughput to 80 megahertz, and my throughput generally cuts in half, so I was down to about 900 aggregate, and I reduced the bandwidth. But being that these run in 6 gigahertz, the spectrum is still pretty virgin, so I would not have any problem running these on 160 meg channels. So the BreezeAIR AXE lives up to its reputation. In point-to-point mode, about 1.8 gigabits per second aggregate when you split 50-50, uplink and downlink. It can be deployed in point-to-multipoint mode also, with many SUs communicating to a single master unit. And connectorized versions, we could use sector or horn type antennas for even more flexibility, and go from there. So Telrad tell me that the roadmap looks something like this. That we're going to take and get up to 1024 QAM in a 2x2 mode, which is going to push us over the 2 gigabits per second link speed. Ultimately, going to be able to put 4 channels together, or use carrier aggregation for 2 channels and then 4 channels ultimately, and that's going to push this little system past 4 and 8 gigabits per second. So, and whether we're doing point-to-multipoint or point-to-point, we still have the same type of performance. Its previous version of equipment was the BreezeAIR 8000, of which I had a test set in my lab also, and it would do 300, give or take, megabits in proprietary protocol. This was before 802.11ax, and so in my lab, this system, I ran it right beside another point-to-multipoint system using 80 megahertz of 5 gigahertz channel, and both systems performed beautifully together. I knew the point-to-multipoint system, the other system, would perform. I was concerned mounting the antennas in that very close together for the subscriber units for the BreezeAIR, and my issues did not materialize that I expected to. I still had all the throughput in the world. So this is a system that I'm recommending, and if you want a light point-to-point, a light point-to-multipoint, this is it. We've just recently, MBSI WAV and WAV LLC in the US have just recently become distributors for this equipment. So feel free to inquire, and as usual, any feedback or comments that you have on this Tech Talk or any other Tech Talk, I welcome. Send your email to marketing@mbsiwave.com, and any new topic suggestions, same thing. Send them to me at marketing@mbsiwave.com, and who knows, maybe the next Tech Talk is going to be your suggested topic. Bye for now.